So in the previous workshop, we discussed about the protocol design, proto design using protocol buffers. So that way we discussed about what are protobufs, what are use cases of protobufs. Then we went through the actual module definition of our NFT module. So how we define the collection, the NFT, and the metadata and the collection denoms and all those things are the CRUD operations, minting, transfer, burning NFT, and update NFT. How we can define those in our protocol buffers. We discussed those. We discussed the CRUD operation in details. Then we defined how we can generate the PB definition files. Those things we discussed. And then we discussed about the queries or the data endpoints, how we can get those data endpoints. So those things we discussed using protocol buffers, how we can define them, those structures. Now we'll go to the next part, in which we'll discuss about the transaction and query commands. So basically, these are the entry points of our module. So how we can interact with the module. So using transaction and query commands. So those we'll be discussing. So to discuss these, first we need to discuss what are Cobra commands. So Cobra commands basically refers to commands implemented using Cobra library in Go. So Cobra is a very popular command line interface library that helps developer create a powerful, modern, and feature-rich command line applications. So in Cobra, basically a command represents a specific action or operation that the CLI application can perform. So it allows you to define and organize your application functionality into separate commands, making it easy to handle different use cases and scenarios. So now we look into the use cases of these Cobra commands. So first are the hierarchical structures. So Cobra allows you to create a hierarchical structure of commands where commands can have a child command and form a tree-like structure. These enables the organization of related commands under a common parent command. So these hierarchical structures you can define using Cobra commands. Seconds are flags and arguments. So commands can have associated flags and arguments that provide additional input parameters for the command. So flags are used to set configuration options, toggle specific behaviors, while arguments represent the actual value or parameter required by the command. So you can pass parameters using flags, or you can pass using arguments. We'll see both in details when we go forward. Next is the execution logic. So each command has a corresponding function that represents and defines the execution logic of the command. So when a command is invoked, the associated function is called. So each command has its own functions. So allow you to perform a desired operation or actions based on provided flags and arguments that you pass. So those execution logics are defined by these Cobra commands. And so these are passed by the Cobra commands. So next is the command line parsing. So Cobra handles command line parsing and routing for you, making it straightforward to extract flags, arguments, and other inputs from the command line passed to the users. So these things that they do. Next is this help and use. Basically, Cobra command generates help and usage information for each commands, making it easy for users to understand the available commands, their flag arguments, and how to use them. So users can also use -- help command that we'll see next to get the details of the information about the specific commands or the overall application. So these things are these are useful features of Cobra commands that we'll be using. So using Cobra commands, you can create a complex CLI application with multiple commands, each serving its own purpose and functionality. This is the modular approach that allows for easy, extensible maintainability and consistent user experience when interacting with CLI application. So overall, the Cobra commands provides a powerful framework for building command line interface in Go, offering flexibility, ease of use, a rich set of features to create interactive and user-friendly CLI interfaces. So these are the basic things that need to understand before going forward. So these are basics of the Cobra commands. So now let's hop back into the code. So in the previous workshop, we saw how to create a proto under the proto file, and we can define this proto under these NFT. So you can see all we have defined in the previous workshop. And next we generated the PB files, the protocol buffer files under types. You can see here we generated. Now we'll hop into the client one. So under client, first we'll go to transaction.go. So here you can see these are auto-generated code from Ignite command that you might have used to generate the module. So these are basic settings of these Cobra commands. So first is the use cases. So we'll define the use as the module name. The module name is the NFT one, and there's a short command to just understand what does these transaction command do. So basically these are NFT transaction short commands. And what is this disable flag parsing? So disable flag parsing disables the parsing. If it is true, all the flag will be passed to the command line argument. Otherwise, it's made to false. So generally, it's made to true because you don't need to interact with the the user need to interact with the entry points. So basically, that's why we need to keep it as true. So you can see this NFT transaction subcommands. If I go to the CLI and type condex tx nft, you can see here these are the basic commands that are available that we will go one by one. So you can see nft transaction subcommands. So these subcommands are basically they get from here. So now we'll get into details. So we'll start with the first command. The first of our CRUD operation is basically to create a collection. To create a collection, so what I'll do, I'll just create a function here. Name it as get command for create. Then I will name it as this, and this will be basically a Cobra command, and we'll use command. We'll get the Cobra command here. Cobra dot command. Then initialize it, and we'll set it as use. It as use is basically the name. How what name that you give. This is wait. This is as create, and this is create and use. And another thing that we can pass is the arguments. So as we discussed here, this is a create denom. So this symbol will pass this symbol as an argument and the rest of the thing as a flag. So I'm showing both of these so you can understand how we can pass both this as an argument and as a flag both. So we'll use this create, and this will be passed as symbol. So, and one more thing that we use is this long to get the more information about what does this command do. We use strings. We'll just trim this in space empty dot print as printf. What does this do? We'll define it here using backtick notations. Create a new denom. So what we are doing, we are creating a new denom here. So we can add further information that how you can create a new denom and all. So what I'll do, I'll use an example. Example as this dollar sign dollars, and this represent basically the your binary name basically. TX NFT now create symbol. So this is how it can pass. And if you wanna, we will pass another argument as flags. So we'll pass name as flags. So this is how we can pass name. We'll name it. We'll define flags afterwards. Name will pass the we'll pass name schema. We pass preview URL description. These things will pass as. So you can what you can do is just copy these things. I'll copy this. Now you can see our example is ready with it. And second parameter that we need to pass is basically the version. Version will be dot app, the app version basically. The imported strings here. Now we just need to import ranges strings. Also, now it's yeah. So now this thing, these are the basic structure ready for it. And what we need an argument. Basically, I'm taking symbol as an argument. So I'll accept it as an argument. So we'll pass this, use this cobra dot exact arguments. Exact argument is one. Basically, if we provide more than one, then we need to make sure that the user inputs more than one argument as a parameter. So now in this case, we'll use only one. Run as this is a function for it. So you can create a command which will accept a cobra command and will pass the arguments here. Arguments are basically passed as strings and will return an error if some error occurs. Look into this. No issue. Use client context. Client context because these commands are necessarily required to take context from the client CLI. Client dot get client context. Get client transaction context. So what does this do? So get client transaction context returns a context from the command with a field based on flags that we define, and if it returns an error, we'll throw an error. If flag query fails. So we'll see these in more details. So what we'll pass is we'll pass the command here and we'll return if error is not equals to nil, then what we'll do, we'll return an error. So this is how we can take the context from the client. Next thing, we'll take this symbol that we are passing as an argument here. So we'll get this argument, we'll define a variable. We'll take it as arguments of 0, basically the first argument. We'll take that. So next thing, we'll need to take the denom name. So denom name, and we'll pass it an error also. Command dot flags. So command dot flags. So command dot flags returns a complete flag set that applies to this command. Basically, it will define the flags somewhere here, and it will return the complete set of all the flags. And from that flag, we are passing a string, get string, and this will be a flag name, flag name. So this flag name, we need to define it. So what we'll do, we'll go to here, flags.go, you can see. And under flags.go, I'll define a flag name, constant. We'll define multiple flags. That's why I'm using parenthesis here. Flag name it will basically be name. So we have defined here, and we need to define a new flag set for this also. So we'll define a new flag set for this. So basically, flag create enum is equal to flag dot new set flag. Import flag. Wait, let me import a correct flag here. Will use multiple imports, new flag set. So this is how we define it. Flag dot, and if it is otherwise, it will continue as an error. It will define a new flag set for the same, and it will return an error if error occurs. Now we'll have another function. We'll define all the flags at once. Okay. So we'll define this create denom dot string name of the flag. Name of the flag will be what we defined it here. Flag name. Flag name, right? So here this is the flag name. What will it denote? Will denote name or the denom. So yeah, it will define the name of the node. So we created all the flag structures. So now we'll go back to here. So this is ready, and if error is basically not equal to nil, so we'll return error here. So this is how we take one flag. So you can see we took an argument called symbol, and we took an flag called name. So this is the flag name. Similarly, we can have flags for everything, flag for schema, description, preview URI, chain ID, from name, and everything. So what I'll do, I'll just use my existing code here. Flag name for schema. And what I'll do is use the entire flag set here. Here, and I'll replace it because here you can see I've defined all the flag set and the new flag set and initialize all the flag set with the empty one. So here I've done that all. So now the next thing after this, we'll need to parse all this flag to our messages. So the messages basically whatever we are getting from here, we need to validate it. So we need to add validation for it. So we need to parse everything to a specific function to get a validation. So what we'll do, I'll pass the message, take the messages, types dot. Now here, what are the things that inside types, we need to define all the validation steps required for this command to pass. So we'll pause it here. We'll go back to the types and define all the validation. Then we'll come back here. So in types.go, for validation, let's create a file, new file as messages. So for this, we are using denom messages dot go. We define a types. We define a package as types. So now we need to define all these validation steps that will be required. So I'll create a function called basically called new message for validation. New message create denom. This will be used for validation of create denom. So what I'll pass as an argument, I will pass as symbol name sorry, schema description preview URI and sender. Sender basically the sender of the transaction. We'll need to validate the sender is authentic or not. Sender string. Okay. So basically what it will return message create denom. So this is message create denom. We need to return message create denom. So inside message create denom, you can see these are basically rendered from PP definition file that we discussed. So this transaction will input these things. So we need to pass this. So first we'll pass let's pass sender first. We'll pass sender as sender. Similarly, we'll pass ID. We'll go back to that. We'll pass ID, but for that we need to generate a unique ID for that denom prefix. So what I did in the utils.go, I have generated a unique ID basically. So these things we'll use here. So what I'll do, generate unique ID. We'll pass denom prefix for that. What is denom prefix is basically complex NFT. I've just used some constants for here. Now the next is symbol. We'll pass symbol here. Symbol is a name. We'll pass name. Description. Schema. URL is URL. Yeah. So we have passed all the messages that we are receiving here. Just a second. Preview URL sender is sender. Just use schema. Yeah. Correct. We'll format it. Yeah. So next thing, we need to define the route for this because which message will be routed to where. So first here we'll pass the message as message create denom and we'll use route and route will return a string. Here will return router key. So it will return a router key for that. Next, we'll return the type of that function. So these checks are basically check all the messages and routes are authentic or not. Message create denom types. Sorry, type will be a string and it will also return a so here we need to return a type string. So for that, I'll define a constant. And the constant will define a type of message create denom. Create denom. So what we'll do, we'll pass it to the return type here. So this is how these are passed. So now these are basic checks. Now we'll go back to now we'll see how each and every checks are performed for every parameter. So for that, let's define another function. Same, it will take message create denom and just name it as validation to validate basic validation first. Let's do basic validation here. Error. Done. So first we'll validate all the denom symbol and all those validations are valid or not. So for that, let's create a new file only as denom validation denom.go. EXEK package types. Okay. So define a package type here. So same thing, we'll use function. Let's see to new denom validation. Let's do a new denom validation here. Let's validate for ID, what we want, a symbol and schema. ID symbol schema. This will be string, so we'll pass it as string here. Now next, all those three will be a string that will pass as a string. Then we'll take the creator. Creator will be of type SDK dot. SDK dot account, and for that we need to import SDK also. Import SDK here. SDK dot, it will be, this creator will be of type SDK dot account. So now wait a second. Yeah, this will be of type, and the next description comma preview view I will be of type again string. So, and let's return a denom for that. We'll pass this denom as return. Under denom will pass, because this denom is basically, yeah, this struct. This struct we are verifying it, validating it. Sorry. So we'll pass similar to that ID symbol symbol. We'll pass name. Why this name we didn't pass it? Let's start a name here also. Name also will be of type string. Name schema creator will be of type creator. This will be of type string. So what we'll do, creator dot to string. We'll convert it to a string first, then we'll validate it. Description has to be of type string description. Review URI will be of type review URI. So although type has to match what we have given in the struct. So in the struct, you have seen we have given everything as a string. So we need to convert first of all everything as a string. So next is, let's validate a denom. Function is validate denom ID. You'll see if the denom ID is valid or not. We'll take denom ID, which will be of type string. We will throw an error if error is returned. Yeah. So we'll take denom ID from here. We'll convert as, we'll use, first of all, we need to import strings. So we'll use the operation of strings here. Strings. So strings dot trims dot trim space. We'll just trim space. If any character is there, we'll trim it. Then we'll use if, first of all, length validation. If length of denom ID is less than minimum denom length. So I have set a minimum denom length as 3. It can't be like, it has to be minimum of 3. So this denom length, minimum length, or if it is less than length of denom. Length of denom is greater than, it has to be between that max. max denom length. Denom ID. You can see max denom length is 64 and minimum has to be 3. So after that, we'll return an error SDK dot. We'll use SDK errors. So for the SDK errors, let's import SDK errors. SDK errors dot. We'll wrap this. We'll define an error for invalid. Name it is invalid denom. So for invalid denom, we need let's define another file for errors to handle errors. So we use errors dot so will be same as package types. So let's define this invalid denom here. So under here, let's define error. Sorry, invalid denom. Invalid denom will be of type SDK. Let's define SDK error also. So it will be of type SDK errors. We need to register this error. First of all, register error first will be of a module name. So let's define a module. Let's set a module name will be 1. For example, this 1, 2, 3 are just code IDs. And just say it as invalid denom. So we have registered an error here. Now we'll go back. We'll go back to this error invalid denom and we'll just pass as invalid denom ID. So we need to just the user that you have passed an invalid denom ID. And need to just say to the just say that length must be between this. Between let's put up a string integer here that length must be between these two digits 3 and 64. First will be of denom ID. This denom ID is this one, invalid denom ID. Second will be minimum denom length. Third will be maximum. This is how we parse the error messages, wrap error message basically, maximum denom length. So it will return an error if these two conditions are met. So this is for denom. And also we need to just like just say that the denom ID only accepts alphanumeric characters. So other than that, we don't accept. So we'll use those conditions for the same. If let's do an alphanumeric checks in the utils.co. I mentioned it here. Now we'll use this check. Let's copy the check. You can see if it belongs with an alphanumeric, otherwise we'll throw an error that it only accepts alphanumeric characters that begin with an English letter. So this is how we check it. Otherwise, if these two conditions bypass, then we'll return nil. We don't throw an error, we'll return a nil. Same thing, let's go back to here. In the messages.denom.go in the validate section, we'll use that function that we just created. If error, because it already throws an error, validate denom ID, will pass denom ID as message.id. Otherwise, error is not equal to nil. So we'll return error. So this is how we go by validation each and every parameter that we take from user basically. So first of all, we validated the denom ID, validation. Similar to the denom ID validation, we can add validation for all the parameter that we have passed. So what I'll do, I'll just use it, just copy that denom validation thing and we'll validate this, replace this file. So you have seen all the validation that I have added here. I mentioned validate for denom ID, validate for symbol, basically a symbol validation, name validation, description validation, and you can see errors are throwing error because we haven't imported or we haven't registered those errors. So what I'll do, I'll just have all the predefined errors ready. I'll just use it. Now you can see all the validations are ready. So just need to import the validation here and use it. So all the validations are here, all the validations. So denom ID validation, we did it. Similar to the denom ID validation, we can use symbol validation, description, URI, all this validation. So now next we'll showing errors. So we need to import it, strings, SDK errors. Strings, SDK also throws an error. So SDK. And yeah, UTF encoding also we use, so we'll use that. We'll import that UTF-8 encoding. So yeah, and if all these checks bypasses, then we'll return an error, return a nil, sorry. Otherwise, the error will be returned. So this is how we can validate each and every parameters that has been taken from the input, that has been taken from the user as an input. So this validation we did it here. And one main major validation is left for signers. Basically, we'll just see if the message, if the sender is a authentic address or not. So we'll use message as message, same message, create denom. We'll get the signer. And use it as account SDK dot account address. So we'll take just form and error, the two parameters. We'll just use SDK dot account address from back32. Basically, it converts the address to a back32 format and just check if this address is valid or not. So message dot, we use sender, I guess. Yeah, sender. Message dot sender. And if an error is returned not equal to nil, then we'll panic it. Panic it is an error. And return, otherwise return last empty SDK account address, and it is from. Yeah, this is how we can validate the account address or basically the sender address. So yeah, this is a validation part of our command line interface is ready. Now what we'll do, we'll go back to our CLI and just use types dot. We have defined as new message create now. We'll just use that and pass everything what we took as an input from the user. So as my sorry, symbol. Next is denom name. Next is schema. Then is description. Then we take preview URI, review, and then pass the client context here. Next, because we have passed everything, we just need to pass the client context and get the address, because the address and the address basically is not passed as an argument. We'll just take as the signer. From the signer, we'll take the address of the sender. So get from address, basically from address, and this from address will convert it to string, because as we saw, we input everything as a string, then we use validation on top of it. Yeah, now we'll go back to here. Yeah, now just format it. Client context. The client context is from address. Yes, yeah. Now we're ready with it, and everything will pass into. We'll check the validate basic. We'll call the validate basic for it, and we'll check everything is correct or not. And we'll throws an error if error is thrown. So we have used validate. We'll pass message dot validate basic. If error is not equal to nil, return add error. So yeah, all the basic validation is done. Just will come back and lastly return transaction dot generate or broadcast CLI. So what does this mean? This just generate or broadcast CLI. So generate or broadcast CLI will either generate and print the unassigned transaction or sign it and broadcast an error upon failure. Basically, it just checks if error is returned, it will throw an error. Otherwise, it will send to the next step, broadcasting it to the keepers basically. So this is how it does. So we'll pass the necessary things. We'll pass the client context. We'll pass the flags, command dot flags, and the message. We'll pass it after that. And the next thing, we'll take everything from the flags as add it, add we have imported add flags. Yeah, okay. So some flags are marked as required and some flags are optional. So first here we are marking as name flag as an required flag. So this has to be taken from the user. So just use the new form cmd dot cmd flag flags flags dot add flag as flag name. And then this is a required flag, and we'll mark it also first of all. So as an required flag. Mark as mark flag required. What flag name as flag name. Yeah. And also we'll set the flag. Let's set the flag here. Set as set flag, and this has to be over here. So we'll set the flag. We have flag marked as flag as required, and now lastly we'll return it. Return the command. I guess this is, yeah. Makes sense. Yeah. So we have seen how we can define the flags, how we can define the arguments, define the flag structures, and all the validation steps required for the transaction to go flow. And these all are the basic validation that need to be taken care before passing it to the keeper. So we have seen those. So this is how the basic structure, how we can define a CLI, how we can validate it. So similar to that, we can also do it for the query commands also. Simple, we can add it in the query command and we can access it. So now we have defined it here. So this will, we have to define it under this. So we can accessible to the CLI. Yeah. This is how we can go forward with it. And I guess we are done for today.